Assalamualaikum and hello everyone. In this session, we are going to solve the problem of a cone clutch. The question is, a cone clutch has a mean diameter of 500 millimeters, a cone angle of 10 degrees, and a cone face width of W equals to 80 millimeters. By using the uniform wear assumption, determine the actuating force and the torque capacity, and also the power capacity for a speed of 500 rpm. The design decision are the lining has F equals to 0.2 and Pmax equals to 0.5 megapascal. From here, we list down all the information given. This is a cone clutch. The mean diameter is 500 millimeters. The cone angle is 10 degrees. The width is 80 millimeters. The assumption is uniform wear. The coefficient of friction is 0.2. The maximum pressure is 0.5 megapascal. And the rotational speed is 500 rpm. Before we determine the actuating force applied, first we find the inner and outer diameters. Since we are given a mean diameter of 500 millimeters, so the equation of mean diameters is the outer plus the inner diameters over 2. And we rearrange the formula become the outer diameter equals to 1000 minus the inner diameter. This becomes the first equation of D. After that, the second equation of D is obtained from the cone angle. Refer to the figure here. We can use a sine alpha equals to capital D minus small d over 2W. And we get the second equation is the outer minus the inner diameter equal to 27.78 millimeters. After that, we substitute the first equation into the second equation, and we get the inner diameter is 486 millimeters. We substitute the value of inner diameter into the first equation, and we get the outer diameter is 514 millimeters. Next, we use the actuating force formula from the uniform wear theory to determine the actuating force value. Since we have the value of maximum pressure, outer and inner diameters, then we get Fa equals to 10.688 kilonewtons. Next, we use the torque formula from the uniform wear theory to determine the torque capacity. We substitute the values and we get T equals to 3077.4 Newton meters. To determine the power, we convert the rotational speed N into omega and substitute the values into the power formula. Then we get P equals to 161.13 kilowatts. That's all for this session. Thank you.